In this section of algebra, we're going to be looking at quadratic equations. Now, if I remember right, in a previous section, we were factoring quadratic expressions. In this particular one here, we're going to be actually finding the solutions, and I'm going to be giving some examples of some different techniques. For example, the old-fashioned way of just factoring, and then we'll use the we'll do an example of demonstrating the square root property, and then we'll go through and do some problems by completing the square, and then I think lastly we will be getting to the quadratic formula, which a lot of students have a hard time with. Um, so we're going to definitely be doing some examples of that, and then we're going to first derive up the quadratic formula actually before we use the quadratic formula by completing the square. So that's what this section is going to be all about. I think actually the last problem, I think I do an application problem, um, a little word problem of some kind. Okay, so let's get started. Okay. So we always start out with something fairly easy and then work up to more difficult problems. Right. And I'm just going to label this here as 1. Okay, so let's say we have 4x squared and it's equal to 8x. Equal to 8x. So we want to find the solutions that make this equation true. In other words, when I plug it in, this side's going to be equal to this side over here. Of course, you know, you could look at this and say 0, couldn't you? I mean, 0 is equal to 0. Alright, well, best thing to do is get this in more of a standard form. 4x squared minus 8x, that's equal to 0. So I just took the 8x over to the left hand side. Now what I'm going to do here is I'm going to pull out a 4 and an x, because there's a 4 and an x in this term, and there's actually a 4 hiding over here in 8. I guess that's the way you can look at that. That's the way I see it anyway. So we have 4x. We're going to pull this out, and so we're left with x minus 2, and that's equal to 0. See? So as you can see, you can take the 4x and just multiply it back inside, and we end up with our original here. Okay, so that's one way to check that. And then what we'll do is take each one of these terms and set them equal to 0. So take each one of the factors and set them equal to 0. Right. And then of course multiplying both sides by 1/4 gives us x is equal to 0, right? I multiplied this side by 1/4, that's going to give me a 1 as a coefficient, and 1/4 times 0 is just 0. And then on this one here we just add 2 to both sides, and so we end up with x is equal to 2. Right, so I'm going to be kind of expecting you to know how to do the intermediate steps. Okay, so you could actually write it like this. I don't think I'm going to. But we could say the solution set is 0 and 2. Right, that's called the solution set. Right, in other words, you plug 0 in, we get 0 over here. Plug 0 in, we get 0 over here. If you plug 2 in, you get 2 squared is 4. 4 times 4 is 16. Plug 2 in here, and 2 times 8 is 16. So 16 is equal to 16. Alright. Okay. We'll label that one as 2. So we have 3x squared is equal to negative 12x. So I want to take this over to the left hand side. So we have 3x squared plus 12x, and that is going to be equal to 0. Now we'll want to pull a 3 out of here, right? So you look for the you want to factor out the largest number that goes into both these coefficients here, and that would be 3. And also we can pull out an x. So we end up with just an x plus 4. Now remember, you can always check this by multiplying this, distributing this back across, right? 3x times x is 3x squared, and 3x times 4 is 12x. So now we take each one of these factors and set them equal to 0 and solve for x. Alright, so this one's pretty easy. X is 0 and x is equal to, so we subtract 4 from both sides to get rid of this 4 here, and we end up with x is negative 4. Alright, so these are our solutions. Actually, these 0 and negative 4, right, to the equation. Okay, we're moving right along. Okay, so this is 3. Looks like we have 11x is equal to 2x squared plus 12. So we want to get this in a standard form. I'm going to take this 11x over to the right hand side. Minus 11x, we'll put it right there, plus 12. Okay. Alright, so this one here is a little bit more difficult when it comes to factoring, because that's all that we're doing here. And so let's see. We have a coefficient of 2. So when we multiply these two terms together, we're going to get this 2x squared minus 11x plus 12. Now here's the kicker. You're looking at 12 over here, right? Alright, so what two numbers can I multiply together to give me 12? Well, 3 and 4. I could actually do 4 and 3. In other words, 3 goes here, 4 goes here, or 4 goes here, 3 goes here. So this is like a trial and error thing going on. And then, actually not 1. Well, no, I guess you could use 1. I'm going to go ahead and write that in there. 1 and 12, 12 and 1. Also 2 and 6, and then 6 and 2. So you got all these combinations. Okay, and I don't know, I'm just going to guess here, 3 and 4, take a shot at the dark. So 2x times 4, now remember, okay, so 2 times 4 is 8, and 8 plus 3, right, see it's 2x times 4 is 8x, and then plus 3x plus 3x, and you add both those terms together and you end up getting, actually you end up getting 11x. Yeah, you get 11x, and so that's actually good. Now since this is a plus sign, this term times this term is either going to be negative and a negative and a negative, because negative 3 times negative 4 is positive 12, or it's going to be a plus and a plus. But the deal is we've got to get a negative right here. In other words, this 2x minus 4x is negative 8x, and the negative 8x minus 3x is, there we go. So I guess I got lucky on that one. Alright, it's a lot of trial and error when it comes to trying to find the solutions for this quadratic if you're going to try to factor it, which in a lot of cases is just a whole lot faster than using the quadratic equation or maybe completing the square. Alright, quadratic formula I should say. Okay, so let's go ahead, actually we have another one here, x minus 4 equals to 0. So we solve for x in this problem and we end up getting x is equal to 3 halves, and or x is equal to 4. So our solutions are 3 halves and 4 for this equation up here. All right. Okay. 4. Alright, in this particular one here, we're going to use what's called the square root property. Actually, what I'm going to do here is I'm going to we're going to look at this by factoring, and then we're going to use the square root property. Alright, so we can factor this thing, can we? Um, Maybe I shouldn't have said that. Yeah. Actually, let's just do the square root property. Okay, because it's simple. You just take the 12 over to the right hand side. I don't want to start confusing everybody certain things. So we'll just stick with that. Take the 12 over, and then what we'll have to do here to get rid of this square, okay? To get rid of the squares, what we'll need to do now is we'll have to factor. I mean, not factor. All of a sudden, I zoned out. We're going to take the square root of both sides. That's the reason they call this the square root property. But if I take the square root of both sides, I must write plus or minus over here on this side, okay? So the square root of a number squared is just the number. So we have x plus or minus the square root of 12. However, this can be actually broken down 4 times 3. 4 times 3, and, well, the square root of 4 is 2, so we end up with plus or minus 2, but we can't take the square root of 3. Well, I should say it's not a perfect square. We can't break it down any further. All right. So the solutions are going to be in this particular one, 2 square roots of 3. Also, we have this minus here, minus 2 square roots of 3, minus 2 square roots of 3. Okay. Okay, we are moving right along.